Remember, if we have some reaction, A going to produce B with some catalyst C, this means that what's actually going on here is that we have A plus some catalyst C going to produce AC, and then we have this guy AC, which is going to produce B plus C. So it's important to note that this catalyst, although it exists in our reaction, it is used up, it is consumed, but then it is also produced. So the net result is that we haven't actually used we've used the catalyst, but the net result is we end up with the same amount that we started with. And that is why, even though this catalyst can greatly lower our activation energy, it means that it's not necessarily going to show up in our overall equation. A more appropriate way of looking at this, a more common way that you might see this, is if you had, say, D plus A, and then you'd start with A plus your catalyst, goes to form AC, then D reacts with AC to form B, and then your catalyst pops off at the end. That would be a much more common way that you'd see this. And you can see an incredible difference in your activation energy. So our activation energy for the initial reaction just on its own could look a little something like that. Whereas when we do it with the catalyst, we could see an activation energy like that for the first reaction, and then like that for the second one. So it can be incredibly useful in lowering our total energy.